to build the binary search tree using the given Inorder and Postorder Traversal. Okay, so this is the Inorder Traversal, and what I'm writing now is the Postorder Traversal of the binary search tree. Now using these two, so we'll go for constructing the binary search tree. F, JF, it is CG, and then KL, H, HD, HDBA it is. HDBA. Okay, now what you have to do now,
A is the root node.
Yeah, A is the root node. You got to look into the Postorder. When you look into the Postorder, always the root node will take the last position. Now if I observe this Postorder sequence, in the last position I have A, that means A is your root node. Okay, I am writing A now. Okay, now here, I'll check where A is present inside the Inorder. So A is here, and all the nodes which are towards the left side of A, so they take the left subtree of A now. Okay, and there are no nodes after A in the Inorder sequence. What does it mean? So for the root node A, there is no right subtree at all. Okay, all the nodes which are towards the left side of A, so they'll take the position in the left subtree of A. Okay, people understood?
Yes, sir.
So there will be no right subtree for A right now, because after A in the Inorder traversal we don't have any nodes. Okay, now I'll go for writing okay, I'll write this now. E. Okay, I don't think I can fit everything into this. So let me write first the letters and then put the box. E, and then what it is, I, C, F, J, B, G, D, K, D, after D it is K, H, L. So all these nodes, they take the position in the left subtree of A. Okay, next. Okay, next thing is, so I want to find the root of this. Okay, now if I arrange, okay, I'll go for arranging this. I is here, E is also here, J, everything is there. Now if I arrange it properly, in this fashion, in the first order fashion, next what I am getting is B here. Okay, before B you have all these things. Just like check here. So compare these characters with these characters. All of them are there. Okay, I is here, and then E is also there. Then J is also there. F is also there. C is also here. I have G here next. G is also here, and then what it is? K is also there. L, H, and D. Okay, and B is also there. Now I have to write this. Okay, these characters in this sequence. Okay, so when I write, the last one which I am again getting is B. That means the left child of A will be B. Let me write in this order now. Here, just below I'll write it. I, E, J, J, F, C, G, K, L, H, D, B. So now in the next sequence, what happens is A, I'll write. Now B, I have found B is the left child of A. Now I have to find out, so what nodes will be the left child of occupy the position in the left subtree of B, and which nodes will occupy the position as the right subtree of B. And to do that, so I should again look into the Inorder traversal. Okay. Now when I look into the Inorder traversal, okay, B is here. Now all the nodes which are before B, correct, that is E, I, C, F, J, they take the position in the left subtree of B. So E, I, C, F, J, okay, they take the position in the left subtree of B. And similarly, so we have the nodes which are towards the right side of the B, except A, because A has already taken its position here. G, D, K, G, D, so G, D, what it is, K, H, L. Okay, they take the position as the right subtree of B. And again, I should go for checking the sequence. Correct? No? I'll arrange the sequence as it is in the post order. Now first I will come, next E. So this I am trying to arrange in this order. Next I will come, next E, next J will come, next it is F, and next it is C. So 5 characters are there, C. And similarly I go for arranging this also as it is in the post order. Okay. Now when I look, which comes first now, in this G itself is the first, and next it is K, and next it is L, and next it is H, and finally it is D. D. Is that clear?
Yes, sir.
Now from this, so we came to know that the left child of B is what? C, and the right child of B is D. So now
D.
my updated tree is A, and then B, and here I have C, because the last node in the post order traversal is the root node. So C is the root node of B. Okay, and sorry, C is the left child of B, and D is the right child of B. Okay, next. So now if I take C, here in the Inorder traversal, where is C? Here. Okay, E and I, okay, C is here. All the nodes which are towards the left side of C, so they take the position as the left child of the node C. So there are two characters, E and I. Okay, and similarly, if I take this C, okay, what is there before B? See, B is already there. B is already here. Now F and J, they take the position as, they take the position in the right subtree of C. It is F and J. F and J. Next is D. Okay. Now if I look D here, so this is the node D. Sorry, in the node D, the left child of D, I don't have space, I'll write here little this side, but you write it neatly. So this is for the right I'm writing, and this is for the left I'm writing here. So the left child of D, okay. So if you look, B is already fixed here. That means there is only one left child for D. That is G. I'll write it directly. This is G. I have to write here. OP, people are following?
Yes.
Okay. So G. And then towards the right, so I have K, H, L, and A I should not write because A has already taken its position. So K has not yet taken its position, H also not yet taken its position, L also not yet taken its position. So K, H, L, and H and L, they take the position in the right subtree of D. Okay. Now again, here I got to decide among E and I which one is the root node. Okay. So again, go for arranging this in the order or the sequence which is there in the post order. In post order, I have I and E. So this is EI. I'll change it to IE. IE. Okay. Now the root node is what now? So root node is, so I don't have space. I'll erase this one. The previous one, let me erase. Let me erase this. This complete thing I'll erase. Okay, I think one character also I've erased here. What is this? IEJ. Can anyone tell what is this character is?
F, sir.
F. Okay. Okay. So now the updated one. So E will be the root node. E will be the left child of C. Okay, I'll update this tree. First is A, the root node. Okay, and then we have B as the left child of A. So B, and then left child of this B is C, and then the right child of B is D. Now the left child of A is E. Okay. Now I can complete this. Okay, and there is only one I left. Now after E, I'll go for checking, in the Inorder traversal. Okay, because I want to find out the left child of E and the right child of E. Now when I look into the Inorder traversal, there is no left child for E, but there is one right child for E, because after I have C, which has already taken its position. That means only one right child for E is I. I'll write I here. Okay. Next, now for D, I have found G. Still for C, I have not yet written. Let me complete it. Sorry. Let me erase this. Yeah, F and J I have here. Again, when I check this, it is JF. Let me order this as JF. JF. Okay. So the root node or the right child for C becomes F. Okay, and for this, and I take this JF, F I take here. Okay, so J is the right child for F. Okay, but B has already taken its position, so right child. And if I look into the left side of F, C it is. C has also taken its position. So that means there is no left child for F. There is only right child for F. That is J. OP people are following?
Yes, sir.
Okay. J is done. Okay. Now D. So I have left child for D. There is G is the left child, and now if I take this, I have K, H, and L. K, H, L, and so I need to arrange this in the as per the sequence that is there in the post order. When I look into the post order, so it is K, L, H. I'll arrange it. K, L, H. Okay, that means the next right child for D is H. Okay, I'll erase this now. I've erased it. Okay, I'll update my tree again. A, and then left child for A is B, and then left child for B is C, and left child for C is E, and right child for E is I, and then right child for C is F, and then right child for F is J. Okay, and for B the right child is D. That is what we have found, and left child for D is G. So now by looking into the post order traversal, so among this K, H, and L, I have found that H is the right child of D. Oh, people understood?
Yes, sir.
In this sequence, you have to go for taking the character which comes at the last in the post order traversal. That will be the next root node or the child of the D, right child of the D. Okay. Now we have H as the right child. So now H is the right child. Now if I go here, okay. So to see, I got to look for the character H in order to find the left child and the right child of H. I got to look into the Inorder traversal. So H is here. Towards the left side of H, there is K. That means this, and K has not taken its position till now. That means now K will take the position in the binary search tree as the left child of what? H. Okay. People are following? And now I look to the right side of H, or what's there after H. It is L. I'll check my tree whether L has taken its position. So L has not yet taken its position till now. Now it's going to take the position as the right child of H. So this is your binary search tree constructed using the Inorder and post order traversal. I don't know how many of you had solved it yesterday, Karana, when I gave this problem for you to solve. So those who have solved, Karana, so please verify the tree with this.
It is correct, sir.
Okay. Thank you. Okay. So,
sir, one doubt.
Yeah. Yes, ma'am.
Should we do it in stepwise only, or if we can do it like just in one step, can we do it directly, sir?
No, stepwise. If you do, it is good. I think. Instead of doing it in one step, do it step by step.
Like for last two problems, I was able to do it directly, so I was just asking.
No, it is always better to do it step by step, because you'll get marks for the steps also.
Okay, sir. Fine, sir.
Okay. Okay. So this is how we construct the binary search tree from the given Inorder and Postorder traversal. So now we'll go for the other one. How do we construct the binary search tree from the given Inorder and pre-order traversal? Okay. So that is what we will see now. Okay. I'll go for erasing this or discard this. I hope all of you copied this.
Yes, sir.
Okay.
Yes, sir.
Okay. I'm discarding this now. Okay, this one let me erase. Oh, I think this is retained. I cannot erase it. I'll add a new slide. Okay. So I'm writing the pre-order traversal first. So pre-order traversal, and the pre-order traversal is A, B, C, D, E, F, G, H, I. F, G, H, I. Okay. And Inorder traversal is BCA, ED, GHFI. Fi. Okay. So this is the pre-order traversal, and this is the in-order one second. Excuse me for a while. Yes, sir. Teams. So 10 ಗಂಟೆಗೆ ಮುಗಿಯುತ್ತೆ. ಸಾರಿ 10 ಗಂಟೆಗೆ ಅಂತ 11 ಗಂಟೆಗೆ ಇಲ್ಲಿ ಲ್ಯಾಬಲ್ಲಿ
ಲೋಡ್ ಮಾಡಿಸ್ಕೊಂಡು
ಇವಾಗ ಕ್ಲಾಸ್ ನಿಮಗೆ ಅದು ಇವಾಗ ಕ್ಲಾಸ್ ಇವತ್ತಾ ನಾಳೆಗೆ
ಯಾರಿಗೆ
ಡೇಟಾ ಸ್ಟ್ರಕ್ಚರ್ ಕ್ಲಾಸಸ್
ನಿಮ್ದ ಫೋಟೋ ಕೊಟ್ರೆ
ಅದಕ್ಕೂ ಮಾಡ್ಬೋದಲ್ಲ. ಕನ್ಸ್ಟ್ರಕ್ಟಿಂಗ್ ದಿ ಬೈನ್ ಆಗುತ್ತೆ ಸರ್. ಅಲ್ಲಲ್ಲ ಇನ್-ಆರ್ಡರ್ ಕಂಪಲ್ಸರಿ. ಬರ್ತೀನಿ ಸರ್, ಅಲ್ಲಿರಿ. ಹಾಂ ಸರ್, ಆಲ್ರೆಡಿ 16th ಮುಗಿಬೇಕಿತ್ತು ನಮಗೆ ಟರ್ಮು. ಸೊ ದಿಸ್ ಇಸ್ ಎಂಡ್ ಆಫ್ ಫೋರ್ತ್ ಮಾಡ್ಯೂಲ್. ಅಲ್ಲಿರಿ ಸರ್, ಬರ್ತೀನಿ. Okay. Yeah. So here, okay. So what is the root node? Can anyone tell what is the root node for the binary search tree now?
Sir, A is the root node.
A is the, so you got to observe the pre-order, and the first node in the pre-order is the what? Root node. Okay. So I'll go for writing A as the root node. Let me make two partitions here. So A is the root node, and now I go for observing my Inorder traversal, and all the nodes which are towards the left side of A, so they take the position as the left subtree of A. So there are only two nodes, B and C. They take the position in the left subtree of A, and the rest all, that is E, D, G, F, all these things, they take the position as the right subtree of A. E, D, G, E, D, G, H, F, I. Okay, this. Next, again, you should go for arranging these two. Okay. In the sequence like this, okay, in the pre-order. So I have B and C. So here also B and C is already in the as per the sequence in what? The pre-order. Even in pre-order also the sequence is BC itself. That means the next root node for B and C will be B, or the next the left child for A will be B. Okay, I am updating my tree now. A. So I have found the left child of A, it is B. So I had only two nodes, B and C. Among this B and C, B has become the root node, okay, and C definitely has to be the child of B. Now which child, whether the left child or the right child, again that you can find by looking into the Inorder traversal. So since C is towards the right side of B, so it should be the right child of B. And is there a left child? Is there a left child for B? There is no left child for B. I'll erase this. C. Next. So this is what in the step 1 and in the step 2. Okay. Now I have this. I'll write as it is. E, D, G, H, F, I. Again I go for organizing this E, D, G, H, F, I as per the sequence in the pre-order. So it is from here. A, B, C I have already fixed it. Now here I have to go for arranging it in this fashion. Now last is I itself. I have the I. The next node under. Okay, let me organize. Sorry, arrange it. First one is D. This D, and E takes the next position. And next is F. And next is G. And next is H. And next is I. So the now next root node for these nodes will be D. Okay. So in the third step, A is my root node. Next left child of this is B, and C is the right child. Now I have found the right child of A, it is D. Okay, and the rest all, okay, is going to, okay, and in this D again, so I have to find out these nodes, whether where they'll come, whether they'll come as the right child or the left child. Now if I just take D is here towards the left, so A, B, C are there. That means A, B, C have already taken their position. That means there is no left child for D, and the rest all should will occupy the position as the right child. that is E, F, G, H, I. Okay. Now when I look for this sequence in the pre-order, first letter is E itself. This is already in this sequence as per this sequence. So now the next root node for E, F, G, H, I will be the node E. So in the fourth step, I update my tree and make it as A is my root node, and then B, and then D, and then C here. Okay. Now the right child of D is E. Now if I look into this the okay, oh sorry, I think I made a mistake, so I have to check here. So E, F, G, H, I. Okay. So E is the 1 second.
So G, H, F, I we should write after D.
Okay, where? Here, right? After D. This
Yes.
one. This sequence. Yeah,
G,
can
H,
you?
F.
Sorry, this is the mistake I made. So it is G, H, correct, right?
Sir, in that rectangle box we should write G, H, F.
Oh, okay. 1 second. Here, right? So just tell me where I made a mistake.
Sir, E should come to as the left child of D.
Okay, 1 second. Sorry. So I looked into the pre-order traversal and I wrote this. Sorry. Okay. Got the point. Thank you. We don't have here. So for D, okay. For D, okay, E is the left child. B, A, C, B, they have already taken their position. Since E is towards the left side of D, it comes to the left side here. So this is the only left child for D, and the rest all F, G, H, I, they are going to take the position in the right subtree of D. It is F, G, H, I. Next again I go for arranging this F, G, H, I in the sequence. It is already in the sequence, and the next root node for F, G, H, I will be F. Okay. So in the fifth step, so do it step by step like this. So don't write in one single step the final binary search tree. So B, then D, then C here, then E here. Now F is the root node. Now I look into the Inorder now. What's there towards the left side of F? Towards the left side of F, okay, I have G and H. Okay. So G and H, they take the position in the left subtree of F, and after F, towards the right, there is only one, that is I. I is the right child for F. Okay. Now among this G and H, so H becomes the root node and G will become the left child of H. Okay. Now the finally, I don't go for writing one more, so I'll just modify this itself. I'll erase this. H will be the root. Sorry, is it H? Sorry, G is the root node. G is the root node, and because G among this G and H, G is first, so G is the root node or the left child of F, and then H will be the right child of G. So this is the final tree. So is it correct? Hello? Am I audible? No, did you get the same tree? Okay. Now, I'll give you one more. Okay, try to solve that by yourself, and you have to tell me the final tree for it. I'm discarding this entire thing right now. Okay, so take this. What I'm writing is first pre-order. A B D G C E H I F. Okay, and in order is DG BA HE ICF. Yeah, do this, and you have to tell me the final tree for this. Started? Yeah, can anyone tell what is step 1? Okay. Root node is A, and to left, what are the nodes that can take the position towards the left subtree of A? DGB. Okay. D G B, and others HE ICF, they take the position as the right subtree of A. Next, step 2. Have you identified what is the first? We'll go with the left subtree. It will confuse. We'll finish the left subtree first, and then we'll complete the left subtree first, and then we will go to the right subtree. Okay. In the steps 2, okay, which is the left child of A? B. Okay, A, B. So this one I'll write as it is. So because we'll do this later. So if we take them together, it will confuse. ICF. Okay. So now, yeah. For B, okay, D and G, correct? Where will they come? Yeah, step 3. Okay. Okay. So B is, sorry, which one? I didn't get. So DG, no? D is the left child of B. Correct, huh? Which one? D, no? D is the left child of B, and G is the right child of D. Okay, correct. Next. For D, G is towards the right side. Okay, correct. Next, do this. Find out the root among these. C is the root. Okay, step 3. A, B, this is C, and this is D, this is G. Okay. And now for C, okay, there I think G has already taken its position. E, H, I and F, they take the right side position. Oh, I'm sorry, I have to see this. Okay, I'm sorry. I'm looking at the pre-order. What I did. Okay. For the right child of C is F. Okay, correct here. F. And to the left, you have A is already taken. Okay, H, E, I. Yeah. Among this H, E, I, which is the root node? E is the root node. Okay. A, B, C, F, and next E here, and then this is B. We have D here, and then G here. Okay. Now we have H and I remaining. Okay. If I for E, H is towards the left side. Okay, that means the left child, H is the left child of E, and I is the right child of E. So this is your binary search tree for this pre-order and in-order. Okay. So understood now till here? Okay. And then so I have some more examples. Okay. So these are all the programs. Okay. And applications of binary search tree we need to discuss, and some implementation part on the threaded binary tree, because we have only constructed the threaded binary tree, but we haven't looked into the implementation part of the threaded binary tree. So that is what we need to see, implementation of the threaded binary tree, searching in the threaded binary tree, and then we have the applications of the binary trees. There are only few things remaining here. I hope I can complete it in the next class. So if I do that, I think to some extent the fourth module is fully complete. And then the term days are also extended. I don't want to hurry the things because earlier it was December 16th, the last working day or the term end day, but now it is postponed till January 16th. So still we have plenty of time. So we need not hurry, so we can go slowly, no problem, because we have another one module remaining, that is the fifth module. So since we have plenty of time, we'll go a little bit slow. So even if we go slow, I think by the end of this month I can manage to complete the fifth module as well. So in the remaining 15 days what we get, we'll go for the revision kind of activity. Okay, so we'll do the revision. Okay. Now I think I'll end here for today. So copied this. Okay, I'm discarding. Fifty, 43, 135, 156, 10, 16, 39, 116, 134, Samarth Gowda, absent, 135, 136, 137, absent, 138, 140, 141, 142, 143, 144, 44, 145, Shreyas, absent, 146, 147, absent, 148, 149, 150, 151, 152, 153, 154. 155, 156, 157, 158, 159, 160, 162, 163, absent, 164, 165, 166. 66, 167, 168, 169, 170, absent.